Thank you. This is a man's world. Well, this is a man's world. But it would be nothing, nothing, nothing. That a woman or a girl.
Answer indeed is, well, we can understand better what gravity is. I think we have already a very good description, but we can make a next step by thinking more about, the connection with quantum mechanics.
Okay, excellent. So Priya, can we solve the mysteries of gravity, and if so, how?
Yeah, I think that we can solve the mysteries of gravity, and I think that I agree with both Sabina and Eric that what we are aspiring to is sort of a synthetic description of gravity that combines a microscopic view with a macroscopic view. Einstein's theory of general relativity has been incredibly successful so far in the settings that we've been able to test it, right? So in my opinion, the new theory, and we know Einstein's theory is incomplete. We know that already. The question is, how do we complete it and what will show us the way? And data will show us the way.
Hey Google, what is the mystery of gravity? So I thought, the mystery of gravity. I guess I must have missed something when I read Einstein's general relativity and then studied as much as I could with my limited mathematical skills, Schwarzschild's field equations for the astronomical field of gravity. Look into this, and I Googled it, and Google said, the mystery of gravity, this is the definition of the mystery of gravity, is that it is an attractive force. It actually is very weak compared to the other three main forces. But while the others can both be positive and negative and cancel each other out, gravity is attractive and therefore cumulative with no way to cancel it out. I thought, well, that's awfully strange. We already know that we've determined there's gravity waves coming through space. We've detected them here on Earth. So according to Newton and according to quantum mechanics, with every wave, there's an equal and opposite retraction. So there's a flux in the wave. Look at the ocean, the beach on the ocean. A wave will come crashing onto the sand and then it retracts. So you've got this attractive motion and then you have a flux or a reflexive motion. That is what gravity is. If you have gravity waves, you're going to have both an attractive and a reflexive motion. Just like we have in the atom. We have 2 steps forward, then it retracts 1 step back. 2 steps forward, 1 step back. And that is how the mechanics of the universe works. It's called conservation of energy, and it is uniform throughout the material world because we live in a world of matter, which is atoms with an electron shelf and positive and an atom is basically what the classical physicists used to call a standing wave. Why is it a standing wave? Well, because it has been trapped at one position in space and it cannot escape that position because its escape velocity is weaker than the forces of gravity pushing in on it. So all that little atom or electron can do is to puff up and then move forward. Puff up and move forward. And it stays within its location in space. That is the force of gravity, that it can trap and tear off from the field of the electromagnetic field a little particle and trap it and suspend it in time and space at one location. And then that little atom or electron starts to grow, because as the forces push in on it, it has to either conserve energy by dividing itself and binding itself to another sister or brother atom, or it has to transform itself or convert into a completely different animal, such as a photon, emitting a photon and then binding with a neighboring electron, or etc., etc. This is called the mechanics of the universe, and it is uniform, and it is also the mechanics of gravity. If you have gravity waves, you're going to have both a repulsive and attractive action, and I will show you just in my vision of how this works. And you can see it in the Schwarzschild metric. Schwarzschild metric shows quantum maximum energy is achieved, and then to conserve energy, that little particle moves forward and then collapses again and lets off its excess energy. It's called quantum maximum angular momentum. Move forward to gain a little bit more energy that without exploding or transferring or converting its energy. And then finally, it has to either release another photon or divide itself into a positron or a graviton. There are no such things as gravitons, but positron and an electron, and then collapse again into its resting structure. Everything in the universe, inanimate like chemical, mineral, atoms, pursue their goal of maintaining their structure, and they do this by developing a skin or an electron shelf. Now just look at the organic world. Same deal. We all grow from inside by dividing and differentiating our structure, but we maintain our local differentiated structure by what? Our electron shelf, called the skin. So let me explain it more through some images. But I just want to end this part by saying, I don't understand why this is a mystery. Gravity is both repulsive and attractive. Boom. We know that since Newton. But I don't know if these physicists are purposely trying to misexplain gravity because they belong to some secret society in which this is secret, or if they truly can't picture it in their heads and they can only do the math, which does not give you the mechanical picture of what's happening with gravity. That is why it's so mysterious when they say gravity is the weakest force. No, what's weak is that we're living in a white hole where gravity has compressed and forced everything in our white hole universe to take another form, such as 2C for atoms and 1C for the electromagnetic photons. Bring it together. What does it produce? It produces a gravitational quantum content of at least 3C. C3. So how fast is C3? Well, let me just tell you, it's faster than our solar system. So if you want to push something through at C3, you're never going to see it. What you will see is the after effects of its vibration on the lattice, or what they call Casimir energy, 0-point energy. That leftover gravitational vibration of something swooping through here like a ghost. That is what this whole thing is. You have to add up all the energy systems within a certain system, which is the Earth gravitational field, which is the Earth and its caps, and it's in a capsule. I'll show you why it's in a capsule. That's for a different video. That is for another vision I had. But we are like in a terrarium, okay? And we see up, and what do we see? Blackness. Well, we see, I believe, not an electrochemical universe, we see an electric universe. And what are we looking at when we're looking at the blackness of space? Well, we're looking at the interior wall of a black hole. So we've got a white hole pushing with equal force against the black hole energy, each being C3. And then what's happening on the outside? Well, they're dividing and making other solar system or Earth systems. And I envision it being in a 4-leaf clover times 2, or what we call a Schwarzschild 6 star configuration. And we'll show you how the star seed works, and it works every place in our material universe. And as it grows like Russian dolls or the interior of a beehive. That is what we're looking at. Yes, we can communicate with our sister solar system, but only if we figure out how to communicate through a black hole exterior wall. That's what my vision told me. And I think, I'm not a mathematician, but I think it's a fairly clever solution to some of these nagging problems that the physicists seem unable to grapple with, such as maintaining that gravity is the weakest force in the universe when it's the entire energy of the universe is gravity. Not the universe, the entire energy of our solar system. Because we really operate independent of other solar systems in our particular quadrant, or what should I say, 12th quadrant of our 3D beehive with our 3D cellular, and it's based on the Lie 8 geometry. So let me just finish up. I think what the physicists are mistaking, or perhaps purposely concealing, is that the field equations are a topological geometric representation of gravity in our universe and the torsion that each planet puts on the surrounding space. So it torques. And that's why light, which conserves its energy by taking it the path of least resistance, bends around planets as it swoops by in its C2 traveling train. I mean, it's a train that does not stop. And if it stops, time stops. And I can also envision that in my mind also. So this is my first explanation at a different way of viewing the universe. It's not electrochemical. It's, as Velikovsky, Einstein's friend and colleague, said, it's electromagnetic. What we're seeing is not fusion, but fission, but electromagnetic interactions. And you can base them on Maxwell's equations and Faraday, etc. It's the old classical physics that has been around forever. just because somebody puts it in a different terminology, such as Einstein's general relativity, does not change the fact that as above, so below, on earth as in heaven. You just multiply the mechanics of quantum mechanics outward as it gets bigger and bigger. It doesn't change. It changes form, or it might change color, it might change harmonics, or it might change all sorts of things. But the mechanics is always the same. It's called conservation of energy through conversion into a different form of energy, or a dividing into two lower energy state particles.